Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and in this episode, which is part 10 and also the final video, I'll be talking about Rudin's bullshit of unreal analysis, and the focus will be on integrals. So let's begin. Now, chapter 6 is the last, let's say, semi-sane part of his book. I mean, it's badly written, that this poor idiot has no clue of how to express what he thinks, or even he has no actual knowledge of the facts. He's completely ignorant. And by the way, before I continue, there's also a baby Rudin. And for those of you who do not know, this was the recommended textbook for math undergrads to study. Okay. And so it's been around for decades. I hear that better written books on the topic exist, but it's a garbage topic anyway. So he says this present chapter is based on a definition of the Riemann integral, a definition. So, in other words, he doesn't even really know what a Riemann integral is. And it's based, and here's how you can tell that he doesn't know. He says, which depends very explicitly on the order structure of the real number line. Now that's a whole lot of garbage. It's smoke and mirrors, okay? Smoke and mirrors. It means absolutely nothing, doesn't belong there. But what he's doing is he's priming you, okay? Coating your brain with more shit so that when you get to the stuff that you just need to take for granted and believe and use the results, you have no problem just accepting it. So by that time, you're at a stage where you're used to this crap and you want to get through your degree or diploma. And so you're just simply playing along and trying to get your head around this garbage is a Herculean task, because it truly is garbage. So then we continue over here where he says, we don't integrate over sets. I'm sorry, still over here. He says integration over sets other than intervals is discussed. What does that mean? That means that he doesn't understand that an integral is a product of two arithmetic means over a given distance, okay? The distance being one of those arithmetic means. So, and also, of course, it has nothing to do with sets, because really, first of all, a real number line doesn't even exist. And if you take an interval like that, this isn't a set. And why isn't this a set, you ask? Well, it would only be a set if you could name all the real numbers in there. You can't. Okay. So it's not a set. Intervals are not sets. They are imaginary sets. I mean, you can write x is greater than 0 and less than 1. That doesn't mean squat as far as set goes. You need to be able to identify the elements. And in a previous episode, I showed you how Cantor's theory of countable and uncountable sets tries to get around this. The idea there is to relate a number to a point on the real number line. You can't. And I'll post a link in the details section to one of the articles which shows you that you can't do that. So, and he begins by saying, let A be a given interval, and by partition P, we mean a set of points like that. But quite frankly, he could have just said, by partition P, we mean A is less than B. But he was an anal retentive asshole, just like most of his ilk are. And this here is totally unnecessary. And then very authoritatively, we write, who the fuck is we? The mainstream morons? Okay, and then notice how he goes to extra length, let me rephrase it. He goes to extremes in order trying to show that the intervals must be equal. All he could have said is that you just need equal intervals from I is equal to 1 to n. One thing mainstream academics love doing is they love saying things like E is an element of R or whatever. That's just total crap. You know, X can't be an element of R unless you know what X is. I mean, if you don't know what X here is on the number line, how can you say it's an element? You can say that's a point, you moron, because look, if you have 2 points like that, two distances, there's always a distance in between. Okay. So if you say X is there, there's no way you're going to be able to find X unless you can find a measure of this distance. Okay. So if you have some not magnitudes, but some ratios which the attempted measure results in pi and e and root 2, you don't have a measure for these. Okay. These are just constants. They're not measures. And the numbers that you use in their place are approximations. Okay, so there's no such thing as a real number line. It's a bunch of crap. The theory that he's taught on that, Dedekind cuts and Cauchy sequences, is riddled with errors. Okay, so continue on down. It begins to talk about bounded functions, which is also a silly term because, I mean, you can't really deal with you can't integrate a function unless it is bounded in the sense that all the values are reachable and there is a highest value and the lowest value. Okay. Otherwise, obviously, you're not going to be able to integrate. So then he goes into fancy explanations with supremums and infimums. All this stuff is totally unnecessary. I mean, this stuff is a given. You need to know that a function is bounded before you can even get there. Okay, so it's just a lot of hand waving, smoke and mirrors. Doesn't not necessary. And of course, it's obvious that one cannot integrate over an over an interval that has infinitely large or small values. So you'll see that Rudin focuses mainly on exotic concepts that are ill-formed in the first place, and he eventually arrives at the Riemann integral on page, I think it's 126. Okay. So let's just go down there. Here you go. So finally, it gets to something which resembles more or less what you see in mainstream, okay, when you write down the limit definition of an integral. Okay, so you're a to b, and then it's equal to the limit of whatever the expression is. So that's pretty much it. The rest of the chapters are basically not mathematics. It's just mathematics and unnecessary to cover them. I can promise you're not going to understand anything in that. You'll only learn how to use the methods, but there's nothing beneficial from that. There's no practical application of it. It's all 100% garbage. Don't waste your time on it. If you're not already a subscriber to my channel, become a subscriber and click like and follow me on academia.edu. And I'm looking forward to presenting a new topic in the next video. So hopefully a lot more interesting than this bullshit. My name's John Gabriel. Till next time, goodbye.